This is Chapter 5 Loops, Programming Exercise 34, Game, Scissor, Rock, Paper. So we're going to play a game of Rock, Scissor, Paper, right? And we're going to run a program that lets the user continuously play until either the user or the computer wins more than 2 times its opponent. And of course, this exercise is as straightforward as it seems. Pretty simple, pretty easy to tackle. Now, let's take a look. The only thing I want to mention in this exercise is just start off that we're not actually physically playing with the computer, right? We're just going to be using some kind of representation for rock, scissors, paper when we input it onto the computer for the computer to know and then do its thing and output what it needs to output. Right? So in this case, what I'm going to do is I'm just going to make it simple. I'm just going to use 0 to represent rock, 1 to represent scissor, and 2 to represent paper. So when I input any of these into the console, the program will just read it as as what I represented right here. All right. So with that, let's tackle this exercise. Now I'm going to create a few variables first. And these variables are going to be called win counter. So let's say win counter variable, and let's set that to 0. And then there's a lose counter. And lose counter, we're going to set that to 0. We're going to create a variable for the user to enter their number. So we call it player RSP, short for rock, scissor, paper. Of course, computer is going to get their own variable too. All right. So hopefully this makes sense as I go further to elaborate what I'm going to use it for. All right. So the best way to tackle an exercise like this, where you're constantly playing with the computer until one of you lose, is to use a loop, is to keep running this game until a scenario or certain scenario is hit. In this case, the scenario or the event that it's looking for it to stop is basically when either the computer or the user has 2 or more win, right? Or basically 2 wins, 2 more win than their opponent, so to say, right? And to do this, we could use the variable that I just created right here. We'll simply call it our win counter. As long as our win counter is, well, actually no, subtract by lose counter is less than 2. So imagine this win counter. This win counter is basically used to track the users, how many times the user won in rock, scissors, paper, right? So let's say the user won 3 times and then the computer only won once. So it will be, and once right here means the user lost once. Computer won once means the user lost once. If the user won 3 times, it means the computer lost 3 times. That's what that means right there. So basically win counter is 3, and which is the user's won, and the lose counter is the computer's winning. So basically 3 minus 1. Now 3 minus 1, is it less than 2? No, it equals 2. And that's when you know, okay, it's time to jump out of this loop. The user has won 2 times, so we're done. But what if it's the other way around? What if it, let's say the user only wins 1 time, and the computer wins 3 times. So now it becomes 1 minus 3. Well, actually, you know what? I don't want to confuse you, the user. So midway through this, let's just call it player wins and computer wins. All right, that makes more sense, right? When the player wins, I mean the computer lost. When the computer wins, I mean the player was lost. So okay, hopefully this is a better visual. So player wins minus computer wins. Now, once again, what if the computer wins 3 times and the player wins only once? Well, that means it's 1 minus 3. 1 minus 3 is negative 2. Negative 2 is less than 2, so that means the loop is going to continue. This logic here is kind of flawed. Now to fix this logic where this will work for either case, where either user could win, we could use something like the math class dot and then use this ABS, short for absolute, right? So the absolute value of 2 is 2, the absolute value of -2 is also 2. Therefore, this will allow us to satisfy both conditions. All right, so hopefully with that makes sense. And with that, this loop will just keep continuing until either player or the computer wins 2 more times than their opponent. All right, now next thing I want to do simply is to start off the game. So how will you start off the game, right? I simply start off by just generating something like this where it shows to the user, enter rock, scissors, paper, right? Of course, you could always be more explicit, keep saying enter rock, scissors, paper, or rock 0, scissors 1, paper 2, or you could just assume the user has seen this. In this case, for the user, right, for the viewer, to get a better understanding visual on what I'm doing, I'm just going to be a little bit more elaborate and show this. And so this is basically the player's input. So basically, I'll say player rock, scissors, paper will be the input of basically whatever they input, right? Be it 0 for rock, 1 for scissors, 2 for paper. And after that, I'm going to have to figure out the input for the computer. And the computer, I'm just going to randomly generate something. I'm going to just generate something between 0 to 2, inclusive. So it'll be something like math.random, right? Using the math class again, and multiplying whatever it randomly generates by 3. So this will generate us any number from 0 to 2. All right, now after that, we're basically just doing a whole bunch of ifs, right? Whole bunch of if. The first check is to say, hey, if player, so the easiest thing to start off with will be to say if the player's choice, whether it be rock, scissors, paper, is also the computer's choice. So we're just checking for tie. So let's just say checking if the game is a tie. And it's pretty simple. So if computer RSP, I could say player RSP, doesn't really matter, right? Because if they're a tie, then both of their output is the same. And I'm just simply going to say, hey, this is a tie, nobody gets a score. All right, computer chooses scissor. Oops, forgot to put this right here. Computer, oh no, I meant to say 0 is a rock. 0 for rock, all right? And it's a tie. Okay, and yeah, we just have to do that and repeat that for the other option, 1, right? If the computer chooses 1 and you choose 1, and it's a tie. Else, the only possible other option here is basically was it rock, scissors, and paper? It's a tie. So basically, the easiest thing to do right here is to check for a tie. All right. Now the next thing we have to do, well, in case it's not a tie. So let's see. Let's see. Player chooses rock. All right. So we satisfy all tie condition. Now we just have to satisfy all the win condition for either the player or the computer. So we could start from the beginning. Let's start from 0 and go to the bottom, right? Player RSP equals 0. So that's the rock. And then we do a check. So, all right, we don't have to do it any more ties anymore because we already checked with that condition. We say, okay, definitely not going to be a tie. So what other options there are? Well, the next possible other option is if computer chooses 1, which is scissor. So of course rock beats scissors. So we could just do what is it called? System dot out dot print print line. Oops, let me just computer chooses scissor. Let's see, and then we could say something like, hey, because computer chooses scissor, you win, right? Because you choose rock, computer chooses scissor, you win. And because you win, we're going to have to make sure we track this. Everything has to be tracked if you win or lose, right? So we'll just say, oops, we changed it to player wins. So player wins plus plus. So that's one win for you. Now the only other possible scenario, it can't be a tie because we satisfy that condition. It can't be a rock because we already satisfied here. The only other possible scenario is if the computer chooses paper. Paper beats rock. So you lose. And because you lose, that means computer wins. Computer gets the score. Okay. All right. Now let's see. The other scenario is, of course, you choose rock. So after you choose rock, what else could you choose? Well, you choose paper. Now, all we have to do, instead of writing that over again, let's say player chooses paper. Okay, so we're gonna paste that down here, change this to 1. All right, player choose paper. Now, we can't have computer also choosing paper because once again, we satisfy the tie condition right here. If it's a tie, it is satisfied here and only here. So we don't want to repeat that. We don't need to repeat that. So what we could do, we could go to the next one. Let's go to the other possible scenario, which is 0 or 1. In this case, let's go to 2. All right, 2 is paper. So computer chooses paper. So that way I could say you win again. All right, because 1 is scissor. Scissor beats paper. So you win. And now I don't have to change anything else besides this one word. And the other possible scenario is rock. 0, 1, 2. 0 is rock, which is not represented anywhere right here. So therefore, rock could be the only option. And rock beats 1, which is paper. Scissor. Rock beats scissor. And you lose. Computer win. All right, so we got to make sure it's straightforward like that. All right. That way it's much easier to change. And lastly, for the rock, scissor, paper, well, the other option we did tie, rock, scissor, and finally paper. So let's go around circle, put 0 right here. So basically, if you choose paper and computer choose rock, right, rock, then you win. Player wins, plus plus. Otherwise, well, if you choose paper, another option after rock is scissors, and you lose. Now finally, for the final one, if the player does not enter 0, 1, or 2, they enter some nonsensical value that does not help. We simply say, hey, input incorrect, try again. Nobody gets any score. Okay, so we satisfy for the case for if the user choose rock, scissor, or paper, or choose something irrelevant to the 3. And because of that, this for loop runs pretty well. Okay, of course, as we go further into chapters and learn about catching errors, there are those type of errors in this exercise, but let's not worry about that for now. For now, let's make sure just something as simple as this works. All right, so we're going to run the program again. And of course, 0 for rock, paper for 2 for paper, 1 for scissor. And let's give that a try. Enter 0, and then computer choose scissor, you win. Okay, there's something wrong. Computer chooses, oh, okay, no, that's correct. I choose rock, computer choose scissor, I win. Okay, I was thinking of something else. That's correct. So that's one win for me. Let's try 1. Computer chooses rock. Now I choose 1, which is scissor. Rock is 0, so 0. So rock beats scissor, so that's correct. I do lose. All right, so far so good. Let's try 2. Computer choose, wow, I'm so lucky with this run so far. I get a win, lose, and a tie to really show all the code in this, which is great. All right, now computer choose paper. I choose 2. 2 is paper. Computer also choose paper. Therefore, it's a tie and nobody gets a score. So far it's 1-1. So let's go back to the beginning. Computer chooses paper this time, even though the first time I choose 0, which is rock, I won. So that means it is actually nicely randomly generating a number, which is good. Of course, the number is between 0 to 2. Fantastic. All right. So you lose. So that means I lose twice. And I lost. Computer won twice. I lost once. So that's a difference of 1. And now let's enter some garbage value. And of course, that's good. Garbage value is not accepted, which it shouldn't. Incorrect. Input incorrect. And it keeps trying to run the while loop. All right. That's good. Let's put 2. It's a tie. So far, computer 2, me 1. All right. Computer choose rock. You lose. So computer won 3 times. I won once. Therefore, the game is over because of the difference of 2. Now, let's just get a better visual of that. Let's say I wasn't calculating all of that, and I just want to make sure that, let's see, that one of us, won or lost depending on the output. So we could just say something like if player RSP is greater than computer RSP, system.out.print, you won the game with a score of player wins plus to the computers. Oops. Let's put that like that. To the computer, so computer wins. Score. All right, let me see what's going on. It's because in case the while loop never runs, right? So we have to set a default value. Else, so this one just checks if the computer wins. And if the computer wins, display that. Else, you lost the game with a score of blank to the computer's blank. That is good. All right, let's see how that goes. Once again, let's give that a try. 0, 1, 2, 0, 1, 2, 0. There we go. You lost the game with a score of 1 point to the computer's 3 score. What am I? 3 score. 3 points. Of a score of computer. All right, let's try to get a win this time. Even though it's all random. So enter rock, scissor, paper, rock, scissor, paper, rock, scissor, paper. Yeah, you won the game. You won the game with a score of 1 point. Okay, there's something wrong. You won. That's because I switched this around. All right, just make sure. No, that's fine. What am I thinking? That's fine. You lost the game. You won the game with a score of player wins points to the computer's score. You won the game with a score of 1 point to the no, it should be a lost. Well, that's weird because I put if player RSP, player score is great. Oh, what am I thinking? What am I doing? It's not player. It's player wins to computer wins. Oh man, that was just bad. Just bad. Man, I'm tired. All right, 0, 1, 2, 0. Oops. See, there's that kind of exception, which we'll tackle later on in further chapters on how to handle those. For now, we'll just, okay. You won the game with 2 points to compute 0. Points. Come on, Kevin. All right, so we know that this game works, all right? Pretty straightforward game. Very easy to write up, very simple to write up. You just keep track of your wins, computer wins, your input, rock, scissors, paper, computer's rock, scissors, paper, which is tracked by this variable and randomly generated with the math.random class. Then we just keep track of the winnings, whether it be a negative or positive output. As long as we take the absolute value, this will always be less than -2 as long as computer or you win 2 more times than their opponent. And we just simply keep asking user, hey, enter 0 for rock, 1 for scissor, 2 for paper. And we keep looping this over and over, right? And we just keep doing this check inside as well. Okay, so hopefully that makes sense. And that'll be it for this exercise.